name is Nikodimov. I'm a staff technical product manager in the VMware Cloud Provider platform unit responsible for VCD networking. This is a series of demo that I want to do and to talk about some new features in VMware Cloud Director 10.5 related to IP spaces. But before I do that, let me do a quick refresher about IP spaces itself. So IP Spaces was released in 10.4.1 to provide better, more robust, more flexible IP address management in VCD, and to allow the providers and the organizations to manage their IP addresses independently and securely. So IP Spaces, the primary goal of IP Spaces is to provide better IP address management system, but also it unlocks and it provides more features. Like for instance, when a provider gateway is utilizing IP spaces, this provider gateway can be shared, and also you can enable the route advertisement for natively routed networks. Also, you can have a private provider gateway connected with multiple edge gateways, again with route advertisement enabled. Another good and nice feature is that you can easily disconnect an edge gateway from a provider gateway and connect it to another provider gateway. There are three types of IP spaces that you can create. So the first type is the public one. That of course is created by the provider, and this is an IP space that can be shared between multiple tenants. For this IP space you can create quotas, so there is a default quota that you can specify how many IP ranges, how many prefixes from different size can be created. Also you can create custom quotas for the different tenants. There is also a shared IP space that, again, this IP space is shared between the organization, but it's not viewable by the organization, so it is provider managed, and normally this is an IP space that is used for some common services, infrastructure services that are provided still by the provider. And the third one is the private IP space. That, of course, in this situation, this is a dedicated IP space, which means that also the tenant can create this IP space by itself. And there is no limitations, so no quotas, no limitations of how many IP ranges, how many IP prefixes can be created and can be utilized by the tenant. So in VCD 10.5, we are releasing a few new features related to IP spaces, and the first one that I want to talk about and that I'm going to explore in a demo after that is for the default NAT and firewall auto configurations. So in VCD 10.5, we have these additional features possible in the network topology, possible to be enabled by the provider, and after that to be utilized to automatically create default NAT, no NAT, and firewall rules for intended topologies. So that when the tenant creates his networks, automatically the traffic to be able to communicate with outside of the VCD environment. So the procedure for this auto configuration is a manual, and this auto configuration, it's possible to be done on the edge gateway that is connected to this particular provider gateway with these IP spaces and this functionality enabled. But it can also be done on a private provider gateway that is backed by an active state by tier 0 gateway or VRF. Of course, when you're doing that on the private provider gateway, the NAT and firewall rules that are going to be configured currently are not visible in VCD. Those are visible only from NSX, and that's something that we are going to improve in the future releases. Another new feature that we are having is that when the IP space is attached to the provider gateway with an IP space uplink. Now you can granularly select to which particular tier 0 interfaces this IP space is actually attached to or mapped to. So this basically means that later, and by using different IP spaces attached to different tier 0 interfaces, later you can configure different source NAT rules, for instance, when the traffic is going from outside, from one interface or from another interface on the provider gateway. So now let's quickly walk you through the lab topology that I'm having, and that we are going to explore some of these features just in a bit. So I'm having a single tenant, tenant alpha. This tenant currently has a single edge gateway that is connected to a public provider gateway. This public provider gateway has an IP space that is attached with some IP ranges, IP prefixes created, and also for this particular IP spaces, later in the demo, I'm going to enable this default auto configurations features to explore what's going to be created and to basically to check and to ensure that there is not going to be problem from traffic perspective and the application is going to work as expected. So currently I have a DMZ network that is a natively routed network. So I can access this network from outside directly. And also I have a production network that is attached to this edge gateway. So this is this 172.30.0.0 network. So for this particular network, I want to create automatically some NAT rules and firewall rules so that I can provide reachability for this application that I'm running on this network, to provide reachability from inside as well as from outside to the application. So in the first part, I'm going to use the default NAT and firewall auto configuration rule to create those rules automatically, in the same time ensuring that I'm not going to break the communication for the natively routed DMZ network. So that's important in my situation. As a second step, I'm running an NSX Advanced Load Balancer in this environment that is already pre-deployed, and there are some pre-configuration that are pre-done, which I'm going to use to request a floating IP address for a virtual service that I want to create so that I can expose this application to be reachable from outside. So let me quickly show my lab topology. I have two tenants, Alpha and Bravo, but I'm going to focus on the first tenant, Alpha. Then I already have an IP spaces that are created. I have an internet IP space that simulates an IP space or a subnet that I have received from my provider, which is this one, /22. This is the internal scope of the IP space. The external scope is any IP address. And for the features that I'm going to show you, the definition of the external scope is important to be provided. Then I have a single IP range for assigning floating IP addresses for services like source NAT, destination NAT, load balancing VIP. And I have some IP prefixes from different sizes. And actually currently I'm using one of these prefixes, which is the first one that I have requested, and I'm utilizing that for my DMZ network. So let me also show you the quota. This particular IP space has a quota, very restricted actually, from floating IP addresses, and there is a reason for that, because I want to show you some features. And from network topology perspective, what's currently enabled, only the route advertisement is allowed. And this seems to take some time actually to get, but the route advertisement is allowed because, as I said, I use one prefix of this subnet for DMZ network that I'm going to show later. And what I want to explore actually is these new features that are default auto configuration rules for source NAT, no NAT, and for firewall rule that are matching the NAT rule. And as you can see here in the description, the destination for this rule is going to be defined based on the external scope that you configure for this particular IP space. So let's for now just let's discard this, and let's go to the provider gateways. I have a few provider gateways, but the internet one is the one that I'm going to use. And as you can see, this IP space is already assigned as a uplink to this provider gateway. So jumping to the tenant view, and actually let me jump here where I'm logged as a org administrator. Let me show you my application. So I have an application that consists of 3 virtual machines, two web virtual machines, and 1 database virtual machine. And all of these virtual machines are connected to one production network, 172.30.0.0/24, which is not routable actually, or not externally routable subnet. So all actually virtual machines are connected to this production network. And as I mentioned, I also have this DMZ network that I'm using for applications that I want to have natively routing outside of the VCD environment. So from gateway perspective, I have an internet gateway alpha that is created, which actually, if I go here to general, I can see that is connected to the internet provider gateway. But when I'm logged as an org administrator in the current organization, in the tenant organization, I don't have actually the features here to enable this default NAT, no NAT, and firewall rules. This is actually only available if you're logged as a system administrator in the organization. So here I'm logged as a system administrator. If I go to the networking, edge gateways, and internet alpha edge gateway, I see that I have some more actually here capabilities, like the one that I want to explore for auto configuration of NAT and firewall rules. But currently, because those are not enabled, actually I cannot auto configure those. So let me go and enable these features into the network topology, click edit, and let me enable all of this and save them. And now let me go back to the tenant organization. And before to enable actually those features, let me show you that this BIOS router basically simulates my top of the rack router. But currently, actually, the only prefix here, actually there are a few BGP prefixes, but those are just related to the NSX Advanced Load Balancer that I'm going to use later. But the one that I have here on the top is actually my DMZ network. So this is the only one that I currently receive. So as soon as I auto configure, as you can see this time I have this enabled. As soon as I auto configure those features, I will receive some NAT rules and some firewall rules. So actually let me first examine the firewall rules that I have. The DMZ outbound and inbound is something that was pre-created, so was existing before that. The one that actually was auto-configured is this first one, which basically allows traffic from inside that is going to HTTP, using HTTPS and HTTP traffic going to outside, and having source IP address that is this one 243.1. So what exactly is this IP address? If I go to IP spaces and then internet ISP1 IP space, I can see that actually this was a floating IP address, or it is a floating IP address that was requested, and now it's being used for source NAT traffic. I can also, excuse me, check the routing table now, and I see that I'm receiving actually this prefix right now as a advertisement coming from my tier 1 gateway through the tier 0 gateway to the top of the rack router. So let me go back to the edge gateway and to the firewall rules, to the NAT rules this time. So from NAT rules perspective, the first rule that was created is this no source NAT rule, which is for the IP space internal scope CIDR block, because I'm using this actually as a routed IP space for routed network, and I want actually when this traffic is going outside of my domain to be natively routed, to not be NATed. And then after that, I have this default source NAT rule that will NAT everything else, so any internal IP address with this external IP address. And this is the one that I want to use for my production application that I'm running in this production network that I showed you before. So if I check what I can access right now from this, from one of the virtual machines that are connected to this production network, so let me actually ping first my default gateway, and this works of course. But if I try to ping something that is outside, that fails. But the firewall rule actually was allowing only HTTP and HTTPS traffic, so that's expected. Let me try to access something over HTTPS. Unfortunately, that's also failing. So if I go to my firewall rules, the reason that that's failing is because in my lab, actually my DNS domain is outside of the VCD domain, or the VCD scope outside of the NSX domain. So actually what is failing currently, the first thing that is failing is the DNS resolution. So I can fix that quickly here, and that's a new feature that I can edit directly from here, single rule. And let me add here additional services like DNS. And for easy testing, let's also add ICMP. Okay, and save this row. So while I'm here, actually, let me also show you that there are some also new features here. For instance, this rearranging of firewall rules. It's a new feature in 10.5. I can rearrange the firewall rules from here directly. So for instance, I might want actually this auto configured default rule to be my last rule in the table. Okay, so let's see now what I can do from my virtual machine. Can I actually curl? Yeah, so in this situation I can access VMware over HTTPS, and probably I should be able also to ping outside. Good. So my traffic from the internal network, this production network, which is not directly routed to the external, it's currently working. Okay. So the next thing that I want to show is related to requesting floating IP address from this IP space by the tenant. And to do that, I'm going to actually use the tenant view logged as an organization administrator, where I already have NSX Advanced Load Balancer that is integrated in this environment. It is enabled for this particular gateway. I have service engine group definition and also a pool defined. This web pool currently has two backend servers, which are these web virtual machines that I'm having in my application. So what I have to do is to create actually a virtual service and to request a floating IP address for the VIP. So let me try to do that, and before to fill all these features, let me try actually to request a floating IP address from the internet ISP1 IP space. So if I do that, I'm receiving an error, and that's expected because if you remember, my default quota was saying just a single IP address is provided, and I am already using the single IP address for the source NAT functionality. So let's fix that and go to the IP space definition, to the quota. And instead of actually changing the default quota, what we can do is to add a custom quota for this particular tenant. And because this tenant alpha is my favorite tenant, let's give him 5 floating IP addresses. All the rest will stay by the default quota. Okay, so if I go back to this interface here and I try to request an IP address, this time this is going to work, and as you can see, I received an IP address .2 from this particular IP range block that the IP space have. The problem is that I don't particularly like .2 because I already have a DNS defined for the virtual service that I want to create, and this DNS or this IP address that I want to use for this particular virtual service is .5 because the DNS has been created for .5. So how can I do that? Is there any way that actually I can get .5? Of course, during this auto requesting, currently it's you cannot request a particular IP address, but what we can do is let's discard this IP address here and cancel this. We can go actually in the IP space, in this IP space particular that I'm using, in the floating IP addresses here, and I can request all my additional 4 floating IP addresses that I have. Let me just check if I request a new one. This is failing because I don't have more in the quota. And I can mark this .5 that I want to use particularly for my virtual service for manual usage. So let's name this as a web app load balancer VIP. So now if I go back to the virtual service creation, and this time let's fill up all the required information. This is going to be HTTPS virtual service. So the service engine group, which is this one, the pool that is already pre-created. I have to provide the certificate for the virtual service. And now the load balancer IP address. So as you can see, what I'm seeing right now, if I want to request an IP address, I have 3 available. So the 3 available are because I'm using one for the NAT and I have defined one for manual use. So I have 3. So, but I don't really want to request an IP address. What I want to do is to provide this particular one that I want to use for the load balancer VIP. And let's create this virtual service. So as soon as this virtual service is created, let's see what's happening on the AVI side. It should be fast because the service engines are already running. Yeah, the virtual service received the IP address that I expected. If I check the routing, actually right now I should see also a route for the .5 IP address. So my routing seems to be working, and if I try to access this application from outside, unfortunately, it's failing. The reason that it's failing, so I'm pretty sure that the routing is working, and the reason that it's failing, it's related to security. I don't have really a rule that is allowing this internal traffic. So let's actually create a new rule for that. Wipe up. Answer web. The application is going to be HTTPS. Source is going to be any. And destination, I don't have particularly IP sets created for this IP address, but another new feature is that I can add IP addresses directly to the rule from here. .5. And let's save this row. Okay, so hopefully now actually my traffic is going to work as soon as this is delivered. So let's check that. And so my application now it's working just fine. So once again, let's verify at the end what I'm having in my IP space definition. So I have 5 floating IP addresses here. 3 are not used. I can see that. I can see that I have 1 manual that is used, manual definition, and actually right now I can see that is used for load balancing. The one below that I'm using for a source NAT. I have a single IP prefix that is for my DMZ network that I have here created. If I go to the provider view and to the IP space, from here I just can see that there are 5 IP addresses that are allocated for alpha, and also single prefix that is also allocated for alpha. So this concludes this first part of my demo. In the second part, I am going to also to show you another new features, like for instance, migrations of provider gateways that are defined with the legacy IP blocks to IP spaces, and also how an IP space can be utilized by multiple org VDCs.